Okay, this week you have one gas law to learn, and then you've got 2 assignments total for the week until spring break. Woohoo! I know you guys are excited about spring break because I am. I'm ready. I know it almost kind of feels like we're on spring break, but you've got all these assignments to go up with, so it's not really spring break. All right, so we're dealing with the combined gas law today, and as it sounds, it's combining some of the other gas laws. As you can see, you've got the P over T, you've got the V over T, which you've seen that before. If you take out the temperature, you've got P1, V1. This is a combination of a lot of the laws that you've seen so far. Pressure is still measured in atmospheres. Volume is still measured in liters. And temperature is still measured in Kelvin. Pressure 1 would be the first pressure that you come across. Pressure 2 would be the second, so forth and so on. To start this out, you're going to cross multiply. All right, when you cross multiply, you're going to be set up with P1 V1 T2 equals P2 V2 T1. Now, this looks a lot like all the other laws that we've been setting up. Once you cross multiply and you get everything set up, this is a nice little equation to work with. If I'm looking for, in this situation, V2, I would circle V2 and I divide by everyone else that's there. So you'll notice that P2 and T1 are there, so I'm going to divide by those two. So divide by P2 and T1. These go away. V2 equals P1 V1 T2 divided by P2 T1. Now, I just chose V2 randomly. You could have done any of those. So P1 V1. My device is trying to fall. P2 V1 T2 equals P2 V2 T1. And I could have been looking for T2. And I would circle T2 and divide by P1 and V1 on both sides. So you're going to use whatever you need for the problem. So let's do a problem. These do get a little more lengthy because you do have more things to factor in. So once again, we've got P1 V1 over T1 equals P2 V2 over T2. I'm going to cross multiply before I do anything. P1 V1 T2 equals P2 V2 T1. Okay, so that's my generic normal equation. Then I'm just going to go through and I'm going to underline numbers that are in my problem. So in my problem, I have 1.05 atmospheres. I've got 5.0 liters. I've got 20 degrees Celsius, a 0.65 atmospheres, and a negative 15 degrees Celsius. Okay, so to do this, all I'm going to do is pull out that information. Atmospheres, that's going to be pressure, because we know that pressure is measured in atmospheres. And it's the first one given, so it's P1. It's in atmospheres, so I don't have to convert it, because if you'll remember, we looked over here, pressure is measured in atmospheres, volume is measured in liters, temperature is measured in Kelvin. Here we have 5.0 liters. We know liters is a volume, and it's the first volume listed, so it's V1. It is in liters, so I don't have to convert anything. If the temperature where the balloon is released is 20 degrees Celsius, now 20 degrees Celsius does give us a temperature, and it is T1. However, we're going to have to do something with that temperature because it is not in Kelvin. It does need to be in Kelvin. And then the pressure is the altitude. The pressure is 0.65 atmospheres. That's your P2. It's in atmospheres, so you don't have anything else to do with it. And then negative 15 degrees Celsius is going to give you your T2. Now, I'm just going to drop all that information down here real quick. So P1 is 1.05 atmospheres. V1 is 5.0 liters. T1 is 20 degrees Celsius. I do need to turn that into Kelvin. And I'm going to do that by just adding 273, which is going to give me 293 Kelvin. Then I've got P2, which is 0.65 atmospheres, and T2, which is negative 15 degrees Celsius. I do need to also turn that into Kelvin. So I'm going to add 273. I realized that I need to move up. Sorry, guys. And then, so that gives me 258 Kelvin. So the only thing I'm missing in this equation is V2. So V2 just so happens to be what I'm looking for. So I'm going to circle V2, and I'm going to divide by everyone else. Divide by P2 and T1. These cancel. So I'm left with P1, V1, T2 divided by P2, T1 equals V2. And that's my problem. And from here, all I have to do is plug stuff in. P1 is 1.05 atmospheres. V1 is 5.0 liters. T2 is 258 K divided by P2, which is 0.65 atmospheres, times T1, which is 293 K. Now remember, I can't do any of this math unless I cancel units. If I don't cancel units, this math doesn't exist. I can't combine anything. So atmospheres are on top, atmospheres are on bottom, so those go away. Not the numbers, just the units. And then liters are just on top, so we're still stuck with those. And then Kelvin is on top and Kelvin's on bottom. So our final answer is going to be in liters, which makes sense because we're looking for V2. So we know that it's going to be liters. When I do the math, sorry, I should have already done the math. I should get, oh, that answer doesn't look right. I forgot to do parentheses on the bottom. We all know what happened there. If I don't do parentheses on the bottom, it's going to multiply it all. Wow, a whole bunch. So 71.12, which is way different than the answer I got before. It was like 61,000. So 71.12 liters is what V2 is. So hopefully you guys are really good at this from this point. The only other assignment, you'll have an assignment for combined gas law, and the only other assignment you're going to have is where you actually have a mixture of all the gas laws you've seen so far, and you're going to go through and determine which gas law it is and solve it. And then you have a nice little spring break, and we come back from spring break, we still will have one more gas law to learn, and then we'll be done with the gas laws and moving forward. So good luck with this. Let me know if you guys need anything, and I don't mind doing a Zoom if anyone needs extra tutoring. Just let me know.